Hi guys, we are the True Posture team. I'm NgeNuity.
I'm Jiang. First, we want to show you how EMG signal respond to intense muscle movements. For example, now we are exercising bicep, and you can see the EMG signal.
In this project, we focus on the lower back muscles.
And right now we are seeing the sitting straight posture. This is the hunched posture.
The next step is about the signal processing within MATLAB. The function of this MATLAB script is to extract data from the original text file. The fast Fourier transform results will be generated, and the full width and half maximum values will be calculated to show the shifting trend of frequency. After plot out all the slopes in one diagram, you can obviously see the fatigue level difference between two postures and make a conclusion.
Hi guys, we are the True Posture team. And I'm NgeNuity. I'm responsible for the data analysis.
I'm Jiang. I'm mainly responsible for hardware design and setup of the project. So here's some basic project background. Traditionally, surgeons must do microsurgeries like eye surgeries in a hunched posture because they need to look closely into the microscope. However, surgeons have reported back and neck pain after doing several surgeries continuously in one day. So Alcon TrueVision's solution to this problem is the innovative heads-up three-dimensional imaging technology. Surgeons can now do microsurgeries while sitting straight by looking at the monitor in front. The goal of our project is to quantify the muscle fatigue level difference between the hunched and the straight posture by capturing EMG signal from back and neck muscles. So what is EMG? EMG stands for electromyography. It is an electrodiagnostic medicine technique for evaluating and recording electrical activity produced by skeleton muscles. Due to the recruitment of motor units, the EMG signal amplitude shows an increase, whereas the frequency-based mean or median frequency of the total power spectrum shows a decrease of the contraction time. As you can see here in the graph, the median and the mean frequency are fast Fourier transform based, and they are from the total power spectrum. So there are 4 different cases that can be distinguished from muscle fatigue. And in our project, we only focus on the number 3 here. If the EMG amplitude increase and the spectrum shifts to the left. So in our project, we used 3 different metrics to determine muscle fatigue. Amplitude increase, median frequency decrease, and the frequency domain curve shifts to the left. And in our project, we mainly focus on the number 3 here. Frequency domain shifts to the left. And the reason for these changes is that the conduction velocity of the motor actions potentials on the muscle membrane decrease.
Now let me introduce the experiment design. In our experiment, we focus on 3 parts of the muscles. The first one is the multifidus, the lower back muscle. The second one is the transversalis, the upper back muscle. And the third one is the trapezius discendens, the shoulder muscles. Due to limited time and resource in this period of time, in this project, now we only focused on the lower back muscles. which is most commonly reported by office workers and doctors with pain issues. So today, the result we present are the data collected from the multifidus, the lower back muscles. For experiment format, we collect EMG signal data from 6 sensors simultaneously, 3 sensors on each side, so there are 6 sensors in total. For both straight and hunched, we will hold the posture for 30 minutes and collect the data to see how much muscle fatigue is accumulated in a period of time. Here are the 2 postures we use to simulate the microsurgery. The left one is a straight posture, and the right one is a hunch posture. Here are some metrics to quantify muscle fatigue. Before that, I would like to introduce a concept. It's called frequency distribution, or we can call it amplitude spectrum. It is used to describe the power of frequency. It's used to describe the power of the signal in different frequency range. And the first metric we use is full width at half maximum, FWHM, the width of a spectrum curve measured between those points on the y-axis, which are the maximum amplitude. And the second one is the median frequency. We use the frequency after we eliminate the noise signals.
Now I'm going to introduce the hardware part of the project. This is the general hardware block diagram of our project. As you can see here, we have all 6 EMG sensors interfaced with the STM32 microcontroller with analog input. And we have the Bluetooth module that allows wireless data transmission. And the board also draws power from a power bank. So we separated the power pins and the data pins from the USB interface so that it protects the user from the risk of a current surge. This is the STM32 microcontroller we used. We choose this microcontroller because it has enough ADC channels that we need. This is the EMG sensor that we used. It's called myAware muscle sensor, and it has 2 output modes, rectified and raw signal. In this project, we used a raw EMG signal so that we can analyze the frequency information. This is the PCB layout and the final PCB. The top part of the PCB is basically used for power supply and data transmission. The lower part of the PCB, we expose all the pins we need. The software debugging pins, power supply pins for the EMG sensors, ground pins, and analog input pins.
Now, let me introduce our last part, the signal analysis. In this project, all the signals are processed through MATLAB script. There are basically 5 steps in this experiment. The first one is to sanitize the raw data. From here, you can observe a noise point in the raw signal data. From our observation, the noise rate in the experiment is about 1 out of a million, so we can simply delete it or ignore it. The second step is to generate the amplitude spectrum using fast Fourier transformation. The third step is to fit the amplitude spectrum, then calculate the full width at half maximum, the FWHM. And the fourth step here is to examine the frequency shifting trend through the change of FWHM. And the last step, which is kind of optional, is to eliminate the failed dataset. Here's a sample for the failed dataset. It can be caused by failed connection or some other hardware issues because the hardware is not reliable sometimes. Let's go with more details. Yeah, here is the raw signal. The left one is the original raw signal, which is voltage related and it's collected from the millbar EMG sensors. And right side is the amplitude and the scaled raw signal. The right side diagram is plotted out from the left side original signal data. Here is the frequency distribution, the amplitude spectrum. To see the shifting trend of the frequency, we generate the amplitude spectrum graph for every second in the 30 minutes period. From here, you can see the blue line is the amplitude spectrum, and the orange line here is the best fitting curve for the amplitude spectrum. We then calculate the full width at half maximum. It is marked as the half width here, which is 49 Hz. We record the FWHM of each second and plot them out to see the final trend of frequency shifting. Now let's see the result. Yeah, this is a graph after we plotting out all the FWHM in the 30 minutes period. And the slopes of the linear fitting are recorded to show frequency shifting trends. From here, you can see the shifting trends or linear fitting, the slope of it is kind of positive, which means muscle doesn't get really fatigued in this period of time. After we plot out all the slopes we received from previous steps, we receive this diagram. The blue circles here are for straight postures, and the orange circles here are for hunched postures. We can see the average slopes of the straight posture is about 0.0046, which is positive. And for the average slopes of the hunched postures, it's about negative 0.0028. We can see it's negative. When the slope is negative, it means the muscles can get more fatigue. From this diagram, we can see some obvious difference between two postures. Now I believe we can make a conclusion. The straight posture slopes are almost positive, and the hunch posture slopes are mostly negative, which means straight posture may rarely cause the lower back muscles to be fatigued. With the head-up posture, surgeons can better protect their lower back muscles in the surgery. Now, let me show you a video to better know our experiment.
Hi guys, we are the True Posture team. I'm Jiyu Zhou.
I'm Dom Jiang. First, we want to show you how EMG signal respond to intense muscle movements. For example, now we are exercising bicep, and you can see the EMG signal.
In this project, we focus on the lower back muscles.
And right now we are seeing the sitting straight posture. This is the hunched posture.
The next step is about the signal processing with the MATLAB. The function of this MATLAB script is to extract data from the original text file. The fast Fourier transform results will be generated, and the full width at half maximum values will be calculated to show the shifting trend of frequency. After plot out all the slopes in one diagram, you can obviously see the fatigue level difference between two postures and make a conclusion.
That's all for us. We want to thanks to our sponsor, Alcon TrueVision, our instructor, Dr. Yogananda Isukapali, and our TAs, Adi and Kai. Thank you, guys. Any question?
So I have a question about the frequency shift. If you go back to the conclusion slide.
Sure, no problem. It's stuck a little bit.
The one before with the plot.
Yeah.
Yeah. So, oh, sorry, the one before, the one with the plot.
Yeah, no problem. Yeah, it's a little bit stuck. Yeah, got it.
So how much? So it looks clear that there's the red and the blue separation in the two. How much does the frequency shift have to be for you to be able to deterministically say that there was a muscle fatigue? Because I'm looking at the numbers here, right? The slopes.
Yeah.
And the slopes are very small. It looks like.
Really small. Yeah. Yeah, you can see in this project, we mainly measure the EMG signal for fixed postures. Actually, for all the muscles on your body, if you keep a fixed posture, it doesn't get really fatigued, as all the pain issues are caused by long-term fixed postures. Like for a bicep muscle, when we exercise like playing basketball, it may get really fatigued after a period of time of exercising. But for fixed postures, like the muscles on your back, especially lower back, for sitting like hours or a period of time, it may not get really fatigued. All the pain issues are caused by the accumulation of this kind of small fatigues. So even if it is really small, we can still see the difference between them. And in this project, our main purpose is to find if there is really difference between these two postures. And that's why it's really small. And although it's really small, it means something very important.